Yeah. Hi everyone, welcome back. So, today we're going to move one step up, much more complex, and this is where we start getting to real, we're really talking about physical computing projects. What we're going to do, and I'm going to do an example, and then you're going to have to come up with examples on your own. You can, the first part, you're going to repeat my example, and then the second part, you're going to come up with an example of your own. So what we want to achieve is this. I want, as part of a project, so remember, we start, we have, either you have an idea, you have a problem, or you have an exercise or project to do, yeah? So today we're going to start with an idea. And this is where you, as interaction designer, you should start. You're not here to just do the Arduino exercises or to solve a programming problem. You're here to come up with interaction design ideas and to translate them into a physical computing project. So, what idea are we going to have? Well, I want, this is what I want. I want an electronic keyboard okay? And I want it to have 3 keys. So I'm going to have a very small keyboard, yeah? And I want the pitch to change according to the ambient light. So when it's dull, when it's dark, it plays low-pitched keys. And when it's bright, it plays high-pitched keys. So that when I'm at home and I'm playing piano, I'm learning to play piano, when it's daylight, it's high-pitched and everyone can hear it. And when it's getting dark and people might be asleep, like my neighbors, it's low pitch and not everyone can hear it. I could do it per volume, but I'll do it per pitch, just because it's fun. So, how do we do that? So we want 3 keys, and you want high pitch, bright light, when there's bright light, and we want low pitch when there is dark, when it's getting dark. Okay? That's plain English. Anyone has a question about that? Okay. So, what we need to do next is how do we translate that into a physical computing project? Right. So we can translate this like this. So without knowing much, what's an electronic keyboard? It's basically 3 buttons. Because I said 3 keys, so it's 3 buttons. So we kind of can guess few things. We need something that beeps, yeah? And it beeps 3 different tones. We need buttons, and we need 3 different buttons. And then for the light, I told you about it last week. What was it that I showed you? I told you something. Well, if you don't remember, it doesn't matter. But I mentioned to you the light-dependent resistor. It's a sensor to detect the ambient light. And we need a light-dependent resistor to tell us the brightness of surrounding light. Yeah? You're going to do this exercise again. Huh? So I'm doing it now. Then you're going to do it. And then you're going to come up with your own problem, which you're going to try to create. Yeah? So, Now we're starting to get a bit more into the physical computing things. But so far there's nothing new. We know that beeps and buttons, we need to search for resources about that. We've done the exercise with the buttons, so you guys are familiar with this exercise. These two are the new one, but as always, we're going to be lazy and we're going to see if there are resources available. When it comes to the beeps, we'll have a look, and when it comes to the LDR, we'll have a look. When it comes to the buttons, we know that there is a button in the basic project, there's a button project where you press a button and something happens, so that we know. We just need to have 3 of these buttons, because we want 3 buttons to have 3 tones, so we have like a 3-key keyboard. Yeah. So far, so good. Okay. So the translation from the idea to this, you followed, yeah? Because I said I want a keyboard with 3 keys, and I want the pitch to change according to the light. If it's bright, it's high pitch. If it's not bright, it's low pitch. So that translates into what? We need something that's going to beep, that's going to make a sound. So that's one thing. We need 3 buttons, because that's going to be our keyboard. And we need something to see what's the light. And I mentioned it last week, the light-dependent resistor is a sensor to measure the light. Okay? Right. So let's find out if you have any resources available before we start to invent anything. So first resource we know for sure is there, and for which we need not to make any effort, is, let me duplicate this. How is it done here? Duplicate, yeah. So we know that if you go to the tutorial, and we go to the built-in example, we have, for sure, with no problem, we have the button, which we're all familiar with, yeah? Okay. Next, let's see if there's anything to do with beeps. So we go back to the tutorial, and we have a look again. Maybe there is, maybe there isn't, who knows? So basic, no, there's nothing there, blink, bounces, oh, here we are. It's even better than what I thought. There's a 3-key musical keyboard using 4 sensors and you, okay, we can use this, a tone melody. Yeah? Let's have a look at what it does. So, okay, in this case, it's not using buttons, it's using a different type of sensors. But we want to keep it simple, because we're doing other things that are complicated. We want to use the button, okay? So we're going to see how we can solve that problem. And we have here the code. Okay, so we know roughly what this is going to be. It's like the usual. We take the circuit, we take the code, we get everything, and we get it organized. So we have that. Now we need another one, which is going to be for the light-dependent resistor. So we're going to try to see if we have it here. So we can put light. Let's see LDR, if that's going to work. LDR. Maybe it's going to work. Here. I think we have one here. Analog input. So you can have a potentiometer or you can have an LDR. Perfect. So we have the 3 codes. We have the 3 circuits. We have everything. Look here. It's even easier than what I thought. So, because we're lazy, we're going to start with the most difficult one. And then we're going to go for something simpler. So obviously it looks like it's going to be the tone, actually the exact name. It's called a simple keyboard using the tone function. So here's the circuit, here's the schematic. So we can build the schematic here. And because that one has 3, we're going to make it for 4 buttons, because we need to challenge ourselves a little bit, shouldn't we? Yeah? Okay. So, you're all familiar with this approach, so I'm not doing anything new. I'm just doing it on a different project. We start with the circuit that seems the most complicated one. So we have the Arduino. We have the speaker. That's the symbol for the speaker. And we know that the speaker is connected. Oh, you see, it's badly done here because it's like showing you both the same, but it's not. One port is connected to a resistor and then to the port of the Arduino. And in this case, it's oh, hang on, maybe I can click on it. Yeah. So that's connected to digital port 8. And the other one is connected to the ground. Yeah? And remember, that symbol is the ground. So that's our circuit for the speaker. Yeah? Okay. Next, we do the circuit for the buttons. And again, we know that the buttons are here, so we can look at the circuit. So, again, it's standing on the ground, so we all come on with the ground. Then there is a resistor. Then there is the button, which we're going to symbolize as a switch. Because it's a switch, that's what it is, really. So here is the button. And that goes to a port. And on the other side, it goes to 5 volts. So which port are they using? So they're using port 2. Okay, we can use port 2. How many buttons do we need?
3.
We said 4 to challenge ourselves. So, they're all standing on the same ground. We have another circuit. And that's also going to 5 volt, the same 5 volt. And that goes to the and let's put in 3. And then we have another one. That's again 5 volt. And that goes, well, you can do it like this. Oh, here. 4. And then our final one. Yeah? There's nothing, this is just repeating that, as simple as that, nothing new. And that gives us 2, 3, 4, 5, which is 1, 2, 3, 4 key.